The remarkable thing about scientific discovery is that it refuses to belong to any single nation or culture. Knowledge simply flows wherever curiosity directs it, crossing borders as effortlessly as starlight, and that truth became undeniable in late October 2025 when an unexpected series of images from China's Tianwen-1 spacecraft quietly orbiting Mars, far from the political noise of Earth, revealed details of an interstellar traveler that no one had imagined a Martian orbiter could capture. What began as an attempt by Chinese engineers to test extended deep space pointing for a medium resolution camera suddenly turned into one of the most astonishing astronomical disclosures of the year. A sequence of color-corrected frames released through CNSA's public archives showing a long emerald-tinted object drifting beyond Mars's orbit, faint rhythmic jets pulsing from its surface like the breathing of some immense celestial organism. The world now knows this wandering body as 3I Atlas, only the third confirmed interstellar visitor to enter our solar system. And although telescopes in Hawaii, Chile, Spain, and Italy had been monitoring it since the Atlas survey first identified its hyperbolic trajectory, no one expected a spacecraft circling another planet to deliver the crispest, clearest confirmation that something genuinely unusual was moving through our neighborhood. For months, researchers in the West had debated whether the green hue seen in early exposures was a processing artifact or a physical signature. Skeptics dismissed the reported pulses as noise. Some even questioned whether the faint tail bending in the wrong direction was an imaging fault. But Tianwen-1's perspective from a position tens of millions of kilometers away and entirely independent of Earth-based atmospheric distortion settled the matter instantly. The Chinese frames once again showed the same elongated structure, roughly 5 kilometers in length, shimmering with the same cyan-green luminance and most striking of all, trailing an ion plume that arced subtly toward the sun rather than away from it, defying the conventional expectation that a comet-like outflow must always be pushed outward by radiation pressure. That unexpected orientation electrified the global scientific community because if a tail leans inward rather than outward, it implies that charged particles or controlled expulsion mechanisms might be influencing the emission rather than passive sublimation, opening the door to both advanced natural processes and more provocatively technological explanations. Spectroscopic analysis from Tianwen-1 aligned with European and American data, detecting peaks of nickel and magnesium metals that rarely dominate normal comets at such distances. And brightness curves from the Chinese dataset revealed a recurring 6-hour cycle, suggesting either steady rotation or periodic venting events. But what puzzled analysts most was the sheer intensity of the jets. Estimates placed some plumes at nearly 200 kilometers in length, a scale radically disproportionate to the object's size and its remoteness from the sun, since the solar energy reaching it at that distance is far too weak to produce that level of outgassing unless either extremely volatile ices were embedded within the core, or some internal energy source, radiogenic heating, electrochemical instability, or something more exotic was sustaining the emissions. As the data circulated through global observatories, two competing interpretations crystallized, each profound in its own way. A natural explanation proposes that 3I Atlas may be a volatile-rich interstellar survivor, its crust fractured by billions of years of cosmic radiation, forming deep-sealed cavities filled with ancient ESAs that erupt in violent bursts whenever even a modest amount of heat seeps inward. Under this model, the object becomes a type of interstellar hybrid, neither comet nor asteroid, but something altered by galactic exposure, capable of behaviors that mimic controlled propulsion without actually requiring intelligence. The technological hypothesis, however, cannot be entirely dismissed. If the jets originate from internal chambers venting material in specific directions, then the behavior could resemble attitude control or deliberate maneuvering, not unlike how early human spacecraft expelled gas to adjust orientation. This possibility does not claim aliens so much as acknowledge the universe's age. If humanity can send probes drifting into interstellar space, why could another long-extinct civilization not have done the same millions of years earlier? Yet what matters most is not which interpretation ultimately proves correct, but the fact that Tianwen-1's contribution transforms speculation into measurable consensus by confirming independently and from a different vantage point that the anomalies are real, not artifacts of Western telescopes or calibration quirks. For the first time, Earth, Mars, orbit, and solar orbiting observatories simultaneously produced overlapping datasets of the same interstellar object, allowing genuine three-dimensional modeling through parallax and synchronized brightness mapping. China's rapid release of its imagery, free of delay or political restriction, created what many scientists called a rare moment of planetary unity. An instance when researchers from Boston to Beijing, from the Atacama Desert to Tokyo, drew from the same pool of evidence to decode a mystery older than the Earth itself. The public's response, however, leaned less toward technical details and more toward wonder. The Tianwen-1 images circulated across Weibo X and Reddit within hours, and viewers everywhere became fascinated by the ghost-like glow, describing It has a drifting lantern, an emerald shard of ancient time, or a cosmic seed floating between worlds. To the scientific eye, the features carried deeper meaning: the symmetrical spacing of the jets, the narrow reflective streak along the object's waist, the halo of fluorescent dust, suggesting stratified layers inside its nucleus. But to millions of ordinary people, the photographs were simply beautiful, reminding them that the universe still holds surprises capable of humbling modern civilization. As December 19, 2025 approaches the date of 3I Atlas's closest pass to Earth, at a still safe but scientifically ideal distance of about 270 million kilometers, observatories across 4 continents are preparing coordinated campaigns to measure its acceleration, its spin rate, and the timing of its emissions. The Galileo project intends to combine optical and infrared arrays to determine whether the pulses occur in mechanical intervals or natural thermal cycles, and whether the object has fragmented into smaller pieces or remains structurally intact. If it is breaking apart, scattered fragments will glint in predictable formations. If it remains whole and continues accelerating, then researchers must consider whether controlled propulsion is at play. Either conclusion would be historic: a new category of natural interstellar bodies, or the first recognized artifact from non-human engineers. Both outcomes equally transformative. The Tianwen-1 incident carries a philosophical weight as well. It demonstrates that exploration, when unburdened by geopolitical rivalry, becomes a cooperative relay rather than a competitive race. One observatory hands data to the next. One nation fills gaps left by another. And in this case, a spacecraft orbiting a distant planet provided precisely the missing angle the global scientific community needed. In the end, the images from Mars remind us that curiosity unites us across continents and even across worlds. When we picture Tianwen-1 circling above the red desert of Mars, its camera aimed outward into the cold darkness, and imagine 3I Atlas gliding beyond it, in a silence older than humanity, we cannot help but feel connected to something vast. The object does not know we are watching, nor does it care. Yet by observing it, by choosing to look closely, we become participants in the ancient story of cosmic exploration. Perhaps the lesson hidden within this wandering greenlit traveler is that the universe does not send messages encoded in language. Instead, it offers opportunities, glimpses that challenge our assumptions and invite us to grow. And so, whether viewed from a telescope in Hawaii, a laboratory in Beijing, a hillside in Chile, or a spacecraft orbiting Mars, the same truth radiates from this interstellar visitor. We inhabit one sky, one cosmos, and its mysteries belong to all of us, not because they are easy to solve, but because they remind us how much more there is to understand.